Alright, we're definitely not going to do what we did before. I'm going to have to do that after school, that way it blows up on me. Okay. So, this is a piece of copper metal. Now you can report. Okay. So, piece of copper metal, it's about 4.5 grams or so, based on some measurements I did earlier today. What we have, the apparatus that we have a ring stand here with a clamp, a pitcher clamp. This is a round bottom flask. It's actually a flat round bottom flask. If it was a round bottom, we completely round on the bottom. We have to set it in a mantle, but we're not doing that because we're not doing organic. The flat bottom flask right here, the flat round bottom flask, it just has a flat piece to it. That's the only difference between the two. It's 500 milliliters. What this is actually a bridge, a glass bridge that I built a few years ago, and this actually has a stopper on it, and then this is glass capillary tubing. The glass capillary tubing is actually hollow tubing, okay, and all I did was heat the ends of it and bend it down so it actually forms a bridge. What that will do is that will allow for gas escape to come out of this container and go into this one. So you'll actually see the color in this change as well as the color change in here pretty quick. The concentration of this is 15.8 molar, so it'd be 15.8 and then a capital M. This is nitric acid, it's HNO3, so it's H, capital N, capital O, and then a subscript 3, which is kind of below the O. You can look it up on Google. And this is just tap water. You guys saw me put that in there. It's about 850 milliliters of tap water. Okay, so here we go. So what do we see so far?
It turned green.
Green? Yep.
Like an orange.
Definitely green color. There's a brown color in there. It's actually producing a bunch of gas. Okay, that's that brown gas I was talking about earlier. And we also see at the bottom, the liquid that's on the bottom is now getting pushed over. So that's actually a combination of water that's being produced in this reaction, as well as copper, which is kind of where the green color comes from. And then once it gets hydrated in the water itself, it turns the water blue. So here in a second, when this reaction gets a little further along, I'll actually go over there and stir it, and all of that water over there will be blue color.
That's all.
So what's going to happen is this reaction, as it's occurring, as that copper is going over and into the beaker, it's actually mixing with the brown gas in there, which is nitrogen dioxide, NO2. And so the nitrogen dioxide, in formation with mixing with that compound and another oxygen, will actually get in there and make copper nitrate. So anytime we have a copper solution, you're going to have a blue solution, which is why that water over there is actually forming a blue solution. And so if I stir this up, you kind of see this green on the bottom. I'll stir it up, and you guys can actually see the whole blue color there. Okay? So anytime that you guys see a blue solution like that, especially if you're in college chemistry, you should automatically know right off the top of your head that has copper in it. Okay? Unless your professor tells you something different. Alright, but all the blue solutions I've ever dealt with have been copper. Now, are there other solutions that can make blue? Yes. Okay, it's not the only one, but a majority of them are copper based. So what's happening is this thing is starting to equilibrate, and then eventually it will reverse itself, because this is a closed system over here. The only reason that we have gas going over there is because we've given it a reason to go out. If I put that in there and completely close that thing off, what would happen to this? It would explode. We're producing a gas which is much larger in volume than what the glass can contain. So it actually can blow up, okay? And we don't want it to do that. That's not good, okay? So this will take some time to go ahead and equilibrate. At this point, I would go ahead and press pause, because it's